So let's begin our class with the new chapter, Redox reaction, chapter number 8. This is in your first term. So redox reaction means all those reactions where reduction and oxidations occur simultaneously. Simultaneously means together. For example, if one is means reduced, so second one is oxidized. So when reduction and oxidations, both the process occur simultaneously, that reaction is known as a redox reaction. Red and ox. Red means reduction, ox means oxidation. Hence, one species is oxidized and another one is reduced in such type of reactions. So actually, when we heard about this word reduction and oxidation, so some questions arise in our mind that what reduction is, what oxidation is, and how reductions takes place, how oxidations takes place. So there are different versions of definitions with which we can learn oxidation and reduction. So I am telling you this thing on a short page, a single page. Whenever an element gains oxygen, whenever an means oxygen get attached with any element or atom, that forms oxidation, that results in the oxidation. For example, if I have carbon with me, and if oxygen come in contact with carbon and form CO2, so it means when oxygen is attaching with the carbon, it means that is oxidation process, means your carbon is oxidizing. SO2, NO2 means when where your oxygen get attached, it means that element is get oxidized. If we talk about the reduction, reduction is just opposite of the oxidation. How? When the oxygen remove out, that results in reduction. How? If for example, if I have carbon and then if I perform some experiment and remove the oxygen from that carbon, means CO2, from that CO2, and your carbon dioxide will reduce into carbon and two molecules of oxygen separately. So that results in the formation of, that means that results in the reaction that is known as reduction. So addition of oxygen is oxidation, and opposite to that, removal of oxygen or loss of oxygen is reduction. Second point, losing of hydrogen is oxidation and gaining of hydrogen is reduction. Means if hydrogen is adding with something, that results in the reduction, and losing of hydrogen from any compound, that results in oxidation. Okay. One more thing, one more criteria on which we can just describe that what reduction and oxidation is, that we know this thing that elements combined with each other by donating or accepting electrons. Okay, if one element is donating its electron, losing its electron, it means that is oxidizing. Okay, and those elements which accept that electron, it means that get reduced. So losing of electrons cause oxidation, gaining of electrons called reduction. Clear? So on the basis of these three definitions of reductions and oxidation separately, we used to just describe or discriminate between the reduction process and oxidation process. So if you have any reaction and the question is that you have to find which one is reacting, means reducing, and which one is oxidizing. So first criteria is you just first see that either oxygen is adding or removing. If oxygen is adding, it means oxidation. Is removal of oxygen is there, that causes reduction. Second, if oxygen is not there in the reaction even, so that point of time you just think about hydrogen. If hydrogen is losing, it means oxygen. If hydrogen is adding, it means reduction. Just opposite to oxygen. The oxygen and hydrogen just work opposite to each other. Oxygen enters, hydrogen removes. Or loss of oxygen matlab gain of hydrogen. They are just opposite to each other. They can't just remain at simultaneously together in a compound. Exceptions are always there. Third criteria is if we don't have hydrogen and oxygen in that compound, and we can't just discriminate on the basis of the oxygen and means hydrogen between the reduction and oxidation process. So that the third point is losing and gaining of electron. If your element is losing its electron, it means that oxidation takes place. And if the element is gaining the electron or accepting the electrons, it means that reduction is takes place. Next is means let us talk about in terms of oxygen. Means I've just the first point was in terms of oxygen, na, gaining and losing of oxygen. So let's just describe oxidation and reduction in terms of oxygen. Which things, the things which I have just told you verbally, I'm going to give you some examples of these. Okay. Now, in terms of oxygen, the oxidation is gaining of oxygen in a species. So, for example, when your MgO is oxidized, it means it will oxidize to MgO. Mg become oxidized and form magnesium oxide. Reduction is just opposite to that. Reduction is losing of oxygen in a species. So for example, if we have a H2O molecules where oxygen is there and it get reduced to H2 hydrogen molecule. So it means the oxidation is removing, that results in the reduction process. Note that it's the gain or loss of oxygen, not of O2 negative. But there is a difference. O2 negative is an ionic state, and we have to talk about the entire oxygen molecule. Okay. Next, in terms of hydrogen, oxidation is loss of hydrogen in a species. For example, if from H2O, H2O is oxidized to O2. So what happened? Your oxygen is removing out and it gets oxidized to O2. Let us talk about the reduction, the gaining of hydrogen. So for example, when your hydrogen is react with means is reduced to H2O2. But H2O2 is the formula of hydrogen peroxide. Write it somewhere. H2O2 is hydrogen peroxide. So whenever your dioxygen combined with dihydrogen, it get reduced and form H2O2. So it is about the gaining and losing of hydrogen atom, not an ion. Okay, when your atom get attached, not in ionic state. Clear? In terms of electrons, means oxidation is losing of electron and reduction is gaining of electrons. So oxidation is lose of electron in a species. For example, your Mg is oxidized to MgO, Mg from 2 electrons to 10 electrons in Mg2 positive. So what happened when your Mg loses its 2 electrons and become Mg2 positive? It means it gets oxidized. This is the ionic state, na? Mg2 positive means the maximum capacity of Mg is to donate 2 electrons in ground state. So Mg2 positive will be its ionic state. Okay. Reduction means gaining of electron in a species. So for example, if O2 is reduced in H2O2, oxygen from 8 electrons and 9 electrons per O in the O2 to negative. So it means whenever an element loses its electron and become positively charged, for example, same Mg2 positive, Na positive, H positive, they're losing their electron. Positive sign shows losing of electron and the negative sign shows accepting the electrons. Clear? So when means losing of electron will be there, so that is known as oxidation, and accepting of electron will be there, that results in the reduction. Clear? So let's talk about reducing and oxidizing agents. Okay? So oxidizing agents, oxidizing agents are those agents, these are the chemical species that cause the other reactant in a redox reaction to be oxidized. They oxidize the other reactant, but they itself get reduced in that process. Means they just donate their oxygen, they just gave their oxygen to the another reactant in this reaction, and they itself become reduced. And reducing agents work just opposite to that. So there, a reducing agent is a chemical species that cause the other reactants in a redox reaction to be reduced. They reduce the species, but they itself get oxidized in that process. So work of oxidizing and reducing agents are to oxidize the elements or other species which are present in the reaction and become reduced, and reducing agents, they reduce this the elements and become oxidized. Clear? Okay. So oxidizing and reducing agents are like an oxidizing agent is itself reduced when it oxidizes something, and a reducing agent it itself oxidize when it's reduce something. So they just work means opposite to that. They itself get oxidized and reduced while reducing and oxidizing the other elements. So let's just take an example of this. For example, your 2Mg react with O2 and form 2MgO. Okay, so Mg is oxidized. See, addition of oxygen is there. Mg is oxidized and thus is the reducing agent. It oxidizes. So which oxidize means it is a reducing agent. And O2 is reduced. O2 is reduced because since O2 is a simple molecule here, but it get reduced and attached with MgO, Mg, magnesium. And this is known as oxidizing agent. Okay, the thing, the compound or that element which is oxidized is a reducing agent, and which get reduced is a oxidizing agent. This is the minute difference between this oxidizing and reducing agent. So while just writing the equation, you have to keep this thing in your mind, that which one is oxidized and behave like a reducing agent, and which one is getting reduced and behave like a oxidizing agent. Clear? Next is, there is other some list of some oxidizing and reducing agents are there. So let's talk about the simple one to the complex one. The simple one are, best oxidizing agent is oxygen. Means that way with which oxygen is attaching. It means oxygen always oxidize the elements when it get attached with them. Next is chlorine. Why chlorine? We know this thing that Cl2 molecule removing means it's just losing its electron and becomes Cl negative. That is why it behaves as an oxidizing agent. As we know that when this means element lose the electron, okay, they become means this means oxidized, they become oxidized, and gaining of electron is reducing. Okay, reduced process. Next is dichromate ion in acid, manganate ion in acids, manganate 7th ion, 6th and 7th ion in neutral and alkalis, manganese 4th oxide in acids, hydrogen peroxide, concentrated sulfuric acid, iron 3rd salt. These are some oxidizing agents which are generally means which you generally see in most of the reactions. Means they take part in common reactions generally. Let us talk about the reducing agents. The best reducing agent is hydrogen. Whenever hydrogen attached with anything, it reduces that element or species. Reactive metals means when metals has tendency to just means sorry, I just means I just means मैंने इसको थोड़ा गलत बता दिया. Just got means discorrect there. So what happened? Cl negative means acceptance of electron, and positive means donation of electron. So when an element donates its electron, it becomes positively charged. So losing of charge means oxidizing. When I am losing my electrons, it means I get oxidized, and that behave as reducing agents, just opposite to that. Carbon monoxide, carbon, iron second salt, thiosulfate ion 2, tetra thionate ion, ठीक है, ethanedite ion, hydrogen peroxide, sulfate 4th and 2 sulfate 6th, iodide to iodine. So these are some oxidizing and reducing agents. So I think you all realizing that H2O2 is both an oxidizing and reducing agent, as you can see here. H2O2. Peroxide is also a oxidizing agent, and peroxide is also a reducing agent. So this is common for both of them. Why? Because if a stronger oxidizing agent is present, H2O2 is reducing. So it depends on the oxidizing and reducing agent, that what happened with peroxide. If some stronger oxidizing agents is there and some stronger reducing agents are there, so depend on the basis of that, this H2O2 will convert into H2 and O2. So this is an exception. H2O2, hydrogen peroxide, it can behave as oxidizing agent as well as it can behave as reducing agent, but it depend on the reaction where we just added. Okay.